review how to execute the stronger and clearer routine. To summarize the lesson 7A, building quadratic functions to describe situations, part 3, explore. Okay, and it's important to really think about the focus question when executing a summary routine because you want to make sure that you're connecting back to it. So what makes a quadratic function a good model for the relationship between price and revenue? And so on slide, there is a slide that goes over how to effectively execute and implement a stronger and clearer routine, and that's slide 7. If you look right here, it gives you some context for this lesson, and then within the top, you have some beautiful instructional routine resources you can reference. Typically, this routine, when done in person, is students kind of write in response to a question, and then they work together to revise and edit with multiple different rounds with multiple different students to make their response stronger and clearer. In the online world, this may not be possible, so I'm going to talk through another option you can utilize when teaching both asynchronously and synchronously. So for the actual lesson portion, this can be done synchronously or asynchronously, but students need to have time to actually answer the questions on slide 14, fill out the table, and come up with this expression here. If you're synchronous, you might take a moment to ask students to rewrite this expression another way using the distributive property. By doing this, you're kind of guiding them to start to see that this is quadratic. You might allude, what type of expression is this? It's quadratic. How do you know? Etc., etc. Then when students come down to here, slide 15, they're going to plot the points to form this U shape, begin to form this quadratic graph. And they're going to answer this question. Is the relationship between the price of the movie and the revenue in thousands of dollars quadratic? Explain how you know. And so your goal is to give them adequate time to really think about and respond to this question. You will then need to collect student responses that we will use for this portion of the lesson. So when we get to the summarized portion of the lesson, how can we make this explanation stronger? How can we make the justification clearer? We're going to use student work. And so you may either, if you have like a break, maybe they have like a 15-minute break, you might use that time to sift through the work, or you might give students time, allow students to sign off, and then revisit this lesson the next day to execute this instructional routine. And so you would go through the work and you would find some examples of responses that you believe could be made stronger and some that can be made clearer, and you'll choose one from each category. You can also choose a response that you believe could be has a misconception that you see carried through multiple different responses, so you can address that whole group. And so to make a response stronger, you want to have students want to make sure that they're giving evidence, details, maybe providing an example. And to make a response clearer, students want to add mathematical language, use mathematical vocabulary, and just clarify and make their answer more succinct. And so you might provide some sort of anchor chart, some sort of reference for students to utilize to know what it means to make a response stronger and to know what it means to make a response clearer. So then the next day when you come back together, one platform you can use is Jamboard. And so you can have students work on, so the question is, how can we make this explanation stronger? And so one option is students can go in, you can put students into groups, they can work collaboratively, and each group can be assigned a Post-it color, and they'll post on the Jamboard how they believe the explanation can be made stronger. They don't need to actually rewrite the explanation. They just might want to give some feedback as if they were working collaboratively. And if a group agrees with the response, they can just, again, use that little pen to check off that they agree. If they disagree, maybe they can put an X if they don't think that actually is something that should be added. So this student's explanation and answer to the question was, the relationship is quadratic because it is a U-shaped graph. Okay, that graph is beginning to look U-shaped, but we don't know for sure. That is not a strong enough mathematical relationship to justify why it's quadratic. we need to have something about the expression being quadratic. And so we see some examples of things students might say. We need more evidence here. You can say parabola instead of U-shaped graph, right? That person's not getting to necessarily maybe the heart of what we want to make the explanation stronger, but they are bringing in some mathematical language. And then somebody else said you should add how the expression is 18x minus x squared, right? So students, not every response on here might be exactly what you're looking for to improve the explanation, but it's giving students a chance to collaborate and think. The only time you want to kind of knock something down maybe or ask student maybe not just address if it's incorrect is if something is incorrect. You want to make sure you address that whole group. But for this one right here, you can say the parabola is a U-shaped graph. Well, that's more about making it, you can say parabola instead of U-shaped graph. That's more about making it clearer because it's touching on vocabulary, but they're still pointing to something to improve the explanation. And you might just say, oh, they're giving some advice to make it clearer, but how can we make it stronger with mathematical justifications? Okay, and so then we might give an example that needs to be made stronger. Yes, it is quadratic because the answer is squared. Made clearer. How can we make this justification clearer? Well, they use the word answer. We should want to use expression. There's mathematical language. This person is saying, can you give evidence of this, right? A way to make it stronger. You should actually say that the output x times 18 minus x can be written as 18x minus x squared, and this is a quadratic expression because it has a squared term, right? So this person is saying, okay, bring in the evidence, use this mathematical language, and justify. Okay, and so you'll get a variety of responses. So once you collect all the responses, you can come together and you can think about, okay, I see this feedback. It makes a lot of sense. Maybe everybody take a minute or two and just revise their own responses. How can you improve your response to this question based on all of this feedback we're seeing from this exercise? Give them a chance to respond. And then something that you might want to share, or something that's just a resource for you to have, depending on if you want to share with students, is just an exemplar response. A response that was both strong and clear. Yes, it is quadratic. The output x times the quantity 18 minus x can be written as 18x minus x squared, which is a quadratic expression. What makes this response clear? It's succinct. It has clear mathematical vocabulary. What makes it strong? They provided evidence. They showed the expression and said it was quadratic. They gave that example. Okay, so, and maybe that's something you ask everyone to do. Can you just give a reason? What makes this response both strong and clear? You might even provide a Jamboard space for students to rewrite their explanations. So there's an unlimited Jamboard pages. You can prompt students to just go on a page and rewrite their explanation. And this is all depending on how much time you have to execute this closing routine. So in summary, stronger and clearer is a way for students to really practice and learn how to make their own explanations stronger and clearer by reviewing the explanations of their peers.